Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about statistical properties of the random process that are mean, autocorrelation and cross correlation. Now here in this video, we are going to discuss about time averages of the random process. Time averages of the random process properties. So that are mean time average of a random process, autocorrelation time average of the random process, and cross correlation time average of the random process. And time average function. What is the time average function? Consider a random process x of t. Let x of t be a sample function of the random process x of t, which exists for all time at a fixed value in a given sample space. The average value of random process x of t taken over all times is called time average of the random process x of t. It is also called mean value of x of t. So the time average mean is defined as the mean of time average of the random process is denoted as a of x of t or this notation, and it is given by time average mean is given by a of x of t is equal limit t tends to infinity 1 by t integral minus t by 2 to t by 2 x of t dt. So now here the range of the interval is minus t by 2 to plus t by 2. In this interval, the average value is capital T. So upper value minus lower value, the average value is capital T, that is 1 by T. And some of the textbooks, the time average mean value, some of the textbooks, they are followed by limit t tends to infinity 1 by 2t integral minus t to t x of t dt. So this definition and both the definitions are correct. So now here keep in mind, and what is the average value over the interval? In this over the interval, the average value is t, and minus t2 plus t in that interval, the average value is 2t. So keep in mind this point. And the second one is time autocorrelation function. Time autocorrelation function of the random process x of t. So consider a random process x of t. The time average of the product of random process x of t and x of t plus tau is called the time autocorrelation function of the random process x of t. And it is denoted as symbolically Rxx of tau bar or time average, that is A of x of t into x of t plus tau. The product of x of t and x of t plus tau is called as the time autocorrelation function of the random process x of t, and it is given by mathematically A of x of t plus tau is equal limit t tends to infinity 1 by t integral minus t by 2 to t by 2 x of t plus tau dt. So similarly, and this equation is also written as in some of the textbooks, limit t tends to infinity 1 by 2t integral minus t to t x of t plus tau dt. So that is the mathematical definition of the time autocorrelation function of the random process x of t. Now here where tau is a time difference or the shift in time. Next one is time mean square function. In the above expression, that is autocorrelation time autocorrelation function, tau is substituted by 0. The time average of, so tau is equal to 0, substitute tau is equal to 0, x of t into x of t. So x of t into x of t, x square of t. So that is the time average of x square of t is called the mean square value of the random process x of t, and it is denoted as a of x square of t, which is equal to limit t tends to infinity 1 by capital T integral minus t by 2 to plus t by 2 x square of t dt. So this is the mathematical definition of time mean square value of the random process x of t. And next one is time cross correlation function. So now here we have to consider two random process x of t and y of t. So the two random process and its sample functions are small x of t and y of t. The time average of product of x of t and y of t plus tau is called the time cross correlation function of the random process x of t and y of t, and it is denoted as rxy of tau bar or a of x of t y of t plus tau, and it is defined as and it is defined as rxy of tau bar is equal limit t tends to infinity 1 by capital T integral minus t by 2 to t by 2 x of t y of t plus tau dt. So these are the time average of the random process.